In this video, we're going to be finding the measure of an angle given two sides of a triangle. And we're going to round our answer to 1 decimal place. So here we have a triangle for letter A with a hypotenuse of 9 and a side length of 5. We have our theta, our angle, and so that's going to tell us that we have an opposite side that we don't know. We have an adjacent side of 5, and we have a hypotenuse of 9. So cosine is probably going to be best here because we have the adjacent and the hypotenuse. And so if we set that up, we can say that the cosine of theta equals 5 over 9. And so what we're going to do something here is we're going to do something called left multiplication. And so this is going to allow us to separate our cosine and our theta so that we can find what theta is. So we're going to take the cosine inverse of each side, and we're going to multiply this on the left-hand side. And that allows us to then cancel out our cosine, which leaves us with theta equals the inverse cosine of 5 over 9. And then from here, we can go ahead and plug this into our calculator. And so we'll pull up our calculator, and we want to make sure that we are in the right place. So we're looking for degrees. So we'll check our mode and make sure we're in degrees, and we're not. So we'll move over to degrees. There we go. And so now we can go to second cosine, and notice that that gives us our inverse of cosine. And then from there, we can put in our fraction of 5 over 9, and then hit enter, and that gives us a degrees of 56.25. And because we're rounding this to 1 decimal point, that's going to tell us that our theta can be estimated at approximately 56.3 degrees. I want you to try letter B on your own. So go ahead and push pause and work out the problem. And then when you're done, push play, and let's see if you were right. So here we have a theta in our angle, and this should really be marked as a right triangle because it is. And we've been given an opposite side, length of 3, and an adjacent side of 9, and it's our hypotenuse that we don't have. So we won't want to use sine or cosine since we don't have our hypotenuse. Although we could probably find it because we are dealing with a right triangle. But let's go ahead and we're going to use tangent. So here we have the tangent of theta equals the opposite over the adjacent. So 3 over 9. And we can actually simplify that down to 1/3. So we can say that the tangent of theta equals 1/3. And just like we did for the last problem, we're going to do some left multiplication of the inverse tangent, which allows us to cancel out our tangents, leaving us with just our theta. So we're going to have that theta equals the inverse tangent of 1/3. So we'll go ahead and we'll plug that into our calculator. So we'll pull that up. So inverse tangent, so second tangent. And we're going to go ahead and put in 1/3. So if I wanted to, I could just do 1 divided by 3 and then close my parentheses. And that's the same as a fraction. And here I'm going to get 18.43. So if we're rounding this to 1 decimal place, we'll put 18.4. So theta is approximately 18.4 degrees. And here we have both of our answers. Now, what if you're wanting to find an angle in either radians or degrees, and you're not given necessarily a triangle? Can we still use our calculator for that? So let's do one example where we're going to use our calculator to evaluate the expression in both radians and in degrees. And we're going to round it to 1 decimal spot. So here we have the inverse cosine of 0.24. So we'll bring up our calculator, and we know we're already in degrees because that's what we were just using. So we'll do our degrees first. So inverse cosine, let's try that again, inverse cosine of 0.24 and that's going to give us our 76.11. So that rounds to 76.1. So we can say that we have 76.1 degrees. And then we're going to go ahead and do this now so that we have it in radians. So what we'll need to do is we'll need to change our mode to radians. Then we can do the same steps. So inverse cosine, so second cosine, and 0.24. I'm going to go ahead and hit enter. And we're going to get 1.32, and that's going to round to 1.3. So here we're going to have 1.3 radians. And we need to make sure that we put rad there so that we know that we're talking about radians and not degrees.